It's something I want to do and I want to actually shock you. Now, if you're on TikTok, I want you to look at this because I think I didn't get to share it on TikTok. Somebody posted this on Twitter. He said, "Don't sleep on Wikicat. You need to see beyond the now. Hence, I have made this simple table showing you your work, even if you have as low as 1 billion tokens at different market caps. Well done at Samapi." So let's see the table he drew. So it happened to be that Wikicat at $10 billion, the price of Wikicat will be 0.000018. And the value then will be $21,000, $434. $21,000. Okay, let's check something. So after he tweeted, the developer of Wikicat Asamapi came down here and responded. He said, "Did you account for bonds over time at 1% per buy, sell, and transfer in bracket volume over time?" So I decided to go under the comments. Let me see what happened. So the guy who made the tweet said, "I need to come up with an updated table." Samapi now responded, "Use a bond formula if you can." Okay, so let's go here. So I now came to ChatGPT and said, using a 1% bond formula, what will be the price of Wikicat when it hits $10 billion market cap? Current price is 0.007046 and supply is at 545 trillion tokens. Look at what ChatGPT said. ChatGPT said, "We are giving current price, this per token, current supply, these tokens, target market cap, 10 billion. Now, we are also told that is a 1% bond. This means that over time, 1% of the tokens are bond. That is removed from circulation. Therefore, the circulating supply at the time of reaching the target market cap will be less than the current supply." Yes, agreed. However, note that the bond is a process that happens over time. We don't know the exact timeline or how the bond is applied, whether it is per transaction, periodically, etc. But the problem says using a 1% bond formula, which likely implies that we are to assume a 1% reduction in the total supply from the current supply. Now said, let me clarify. If we have a 1% bond, then the new supply will be new supply equal to current supply. In bracket, 1 minus 1 over 100 equal to current supply, which is 0.99. But note, the problem does not specify how many times the bond is applied. It could be that the bond has been applied over time until the market cap reaches 10 billion. However, without knowing the bond history, we are to assume that we are applying a 1% bond to the current supply to get the supply at the target market cap. Alternatively, the problem might mean that the bond is ongoing and we are to consider the supply at target market cap after a 1% bond. But the problem is ambiguous. However, a common interpretation in such problem is that the bond is a one-time reduction of 1% of the current supply. So, supply after bond is equal to 545 kineko. Okay, then the market cap is calculated as market cap equal to price times supply. At the target market cap, we have this. So just look at the figures. That is where I am trying to land. So just note what they are saying. Okay, so look at where they did their mathematics and look at the answer they arrived at. They arrived at $10 billion market cap, the price per one Wikicat will be 0.000185. Now look at what the guy predicted on his table. Look at what he predicted. 0.000183. So ChatGPT gave us 185. ChatGPT gave us 0.0 into 4 after the decimal point, then 185. Then this guy's table is giving us 0.40 after the decimal point, 183. Hey, it's crazy. Do you understand? So it's just 185 here and 183 here. which is very, very close, which is very, very close. So for Samapi to say, did you take into consideration the 1% bond? It means that it will actually go above this. So just know this. You understand? Now, this video is not a financial advice. It's just for what? Educational purposes. If you want to understand more about all of these things, our class is currently ongoing. So just hit us on the DM to actually enroll yourself, okay? Bye.